Hello everyone, today I'm going to show you how to derive nth order derivative formula for the function cosine ax. In order to get nth order derivative formula or general formula for cosine ax function, at first we should perform some derivatives in order to find trend. The first order derivative in cosine ax equals minus a times sine ax, and the second order derivative is the derivative in the first order derivative functions, so we get the second order derivative in cosine ax equals minus a squared times cosine ax. We can keep on doing as many orders of derivative as you like. Here, we just perform the derivative up to 8th order, which is the derivative in 7th order derivative functions. So, we have 8th order derivative in cosine ax equals a power of 8 times cosine ax. From these 8 terms of derivatives, we should be able to find the trend. For example, for the order derivative such as 1, 3, 5, and 7, all terms include sine ax, and the only difference is the minus and the positive signs. However, we should realize that sine 3 pi divided by 2 equals minus 1, and sine pi divided by 2 equals 1. So, we can make a reasonable assumption for the order number n. The nth order derivative in cosine ax equals minus a power of n times sine ax times sine n pi divided by 2. We can verify this assumption by using previously determined 4 derivatives. For example, for the n equals 1, we have minus a times sine ax times sine pi divided by 2, which equals 1. So, based on this assumption, we have the first order derivative in cosine ax equals minus a times sine ax, which is exactly the same as what we get in our previous page. So for the n equals 1, this assumption is right. Similarly, we can verify this assumption by using other 3 terms. Obviously, this assumption is right for these 4 terms. Similarly, for the even number n, we can do the same job. Let's go back to the previous page. As you can see, for the even number n, such as 2, 4, 6, and 8, all terms include cosine ax. The difference is minus and positive signs. However, in this case, we should realize that cosine pi equals minus 1 and cosine 0 equals 1. So, for the even number n, we can make a reasonable assumption that nth order derivative in cosine ax equals a power of n times cosine ax times cosine n pi divided by 2. Similarly, we can use our previously determined 4 derivatives to verify this assumption, such as for the n equals 2, in this assumption we have a power of 2 times cosine ax times cosine 2 pi divided by 2, which is minus 1. So, based on this assumption, we have a second order derivative, which is minus a power of 2 times cosine ax, which is exactly the same as what we get here. So this assumption is right for the n equals 2. Similarly, we can use these three terms to verify this assumption. Obviously, this assumption is right for the four terms here. So we can have an nth order derivative formula for the cosine ax equals minus a power of n times sine ax times sine n pi divided by 2 plus a power of n times cosine ax times cosine n pi divided by 2. By using trigonometric formulas, we can put these two terms into one function, which is a power of n times cosine ax plus n pi divided by 2. However, I should emphasize here that this nth order derivative formula is based on limited terms of derivatives. In order to verify this assumption is right for the general case, we have to prove it mathematically, which will be discussed in our next video. That's all for today. Thank you for watching.